In this video, we'll talk about unisons, fourths, fifths, and octave. We'll deal very briefly with the definition of diatonic and chromatic and how those things are different or relate to one another, and how to invert these intervals, unisons, fourths, fifths, and octaves. Just a little review. As you will remember, an interval is called by its size and quality. The size of the interval is calculated by counting letter names starting from that bottom note and including the bottom note of the interval. The quality of the interval is done or calculated by counting the semitones, the number of semitones between the two notes, that distance. So we have the 5 possible qualities of intervals: major, minor, diminished, augmented, and perfect, but these are not all equally applied to all intervals. Rather, when we're dealing with simple intervals, intervals within the octave, seconds, thirds, sixths, and sevenths receive the quality of major, minor, diminished, and augmented. Unisons, and I put that in parentheses, which will become, I think, clear in a second, fourths, fifths, and octaves receive the quality of perfect, diminished, and augmented. So there are no such things as minor fourths or major fourths or perfect sixths, that kind of a thing. So unison. A unison is an interval that really is a repeated note. It involves only one letter name and the same piano key. The perfect unison at least does. The perfect unison then has one letter name and 0 semitones of distance, right? Since it is a repeated note. Technically, we can call it a perfect unison, this type of unison that includes no semitones of distance, but I've seen it called like that very rarely, both in the literature and in conversation with musicians. Most often, if you mean unison, that's what you mean, a perfect unison. If it is a different kind of a unison, an augmented unison, then you would specify it's an augmented unison, which involves one letter name but only one semitone. And even then, even when it is an augmented unison, most people will actually call it different things like chromatic semitone. An augmented unison is enharmonic with a minor second. Enharmonic, as you'll remember, means intervals with different names and different qualities, but that contain the same number of semitones and therefore sound the same. But even if people will refer to these chromatic semitones or augmented unisons as minor seconds, that is technically incorrect, because a minor second would involve 2 different letter names, whereas a chromatic semitone or an augmented unison is just 1 letter name. So here's a couple of examples of unisons, or parentheses, perfect unisons, where you have repeated notes. It doesn't matter where it is, how high or how low, ledger lines, whatever clef you are using, if they are repeated notes and there's 0 semitones between them, then you have unisons, like middle C, those 2 high D flat, or F sharp, or it could be really super low. And it doesn't matter how many of them, right? You can have sequences of unisons, right? So if you do have repeated letter names, but you have a distance of 1 semitone between them, like in these cases here, C to C sharp, or D to D flat, or F sharp to F natural, these are chromatic semitones or augmented unisons, right? So once again, even if someone refers to them as minor seconds, because they are enharmonic with those, that is incorrect, because they only involve 1 letter name here. So the reason why we call chromatic semitones is, I think, one that opens up this discussion of what chromatic actually means. In order to understand the term chromatic, I think we have to understand what its antonym means, diatonic. Diatonic tones are notes that belong to any given key. So if you are in C major, that means the diatonic notes, the 7 diatonic notes, are the white keys of the keyboard, right? Because you'll remember that C major has no key signature. Chromatic, on the other hand, are notes with accidentals that do not belong to that given key's key signature. If you start playing the black keys and you're in C major, those are chromatic tones, right? C major is just an example. I could have used any major or minor key as long as the notes that you're playing abide by the key signature, then it's diatonic. If they do not, if they include accidentals that are foreign to the key signature, then those are chromatic tones. Chromaticism is used a lot in music for a variety of reasons. Embellishment is one. Sometimes chromaticism connects to diatonic, two or three, or a string of diatonic notes. And very, very often it is used to change keys in the course of a piece of music or song. Octaves. Like Unisons, octaves involve just one letter name. However, they are being played with different piano keys. So it's not the same repeated piano key, right? The repeated note. You're actually looking for the piano key that has that same letter name from where you're starting, but it's the next one to your right or to your left, right? That is an octave higher or an octave lower. A perfect octave, and once again I put that in parentheses because when people say octave, what they mean is a perfect octave is an interval that has 12 semitones. Right? We've seen this before. An octave has 12 semitones. A diminished octave, very rare, is one that has 11 semitones. Same letter name, but you're including an accidental there to reduce that distance of 12 semitones to 11 semitones. Usually, it is just written as its enharmonic interval, a major seventh. Or an augmented octave is one that includes more than 12 semitones, 13 semitones. So you're making something, you're adding an accidental, so it's bigger than 12 semitones. And very rare too, and it's usually written as a minor ninth. So here are a couple of examples. Here's starting from the same notes that we started before. Here's an ascending melodic octave, right, or a perfect octave. And then here's one D flat to D natural. If you look here at D flat and D natural, those are the same letter names, D's, but the amount of semitones between them, if you would count, is 11. And it sounds like this. Right? That's a descending melodic diminished octave there. And here's an augmented octave. It contains 13 semitones. If you would find an F and count to F sharp, that's the number of semitones you'd find. Also very dissonant. Right? And that one happens to be a harmonic interval. Okay, fourths. A fourth involves 4 letter names. We have 3 possible qualities. Perfect fourth, very important interval, contains 5 semitones. Here's an example, E to A. Right, an ascending melodic perfect fourth. If you would count here from E to A, you would count 4 letter names, E, F, G, A, and you'd find 5 semitones between them. An augmented fourth, also very important. You'd get that if you're starting from the same bottom note, you raise that A by a semitone, right, making it A sharp, and thus you have 6 semitones between them. Right? Very interesting interval, also called a tritone. And the very rare diminished fourth is a fourth that includes only 4 semitones. It is usually written as a major third instead in most contexts. It sounds like this. Right? Fifths. A fifth involves 5 letter names. A perfect fifth, we have talked about it when we dealt with the circle of fifths, is one that includes 7 semitones. Here's a descending melodic perfect fifth starting here on C and descending to F. Right? If you count the letter names from the bottom up, including the bottom note, you have F, G, A, B, C. Those are 5. If you count the semitones, you have 7 semitones there. A diminished fifth, also very important, 6 semitones, also known as a tritone. You'll notice that a diminished fifth with 6 semitones is enharmonic with the augmented fourth, which has the same number of semitones. That is why They're both referred to as tritone. Here's a tritone with the same bottom note of F. Right? And an augmented fifth, also common, not as common as perfect fifths and diminished fifths, but also very common, is 8 semitones of distance. Right? So if you have the same bottom note, that F, you do a descending melodic interval from C sharp. Right? So the tritone, you've seen that we have referred to augmented fourths and diminished fifths both by this name of tritone. And what it means is what it really implies. Tritones, 3 tones, 3 whole tones, right? Because it contains 6 semitones, or in other words, 3 whole tones. It is a very special interval and stands out among all of the intervals for a variety of reasons. One of them is that it divides the octave exactly in half, right? So the octave will have 12 semitones, so 6 semitones is the division in half, and what we have, right, is a tritone. It is the most quote-unquote dissonant interval. That word is thrown around like very cheap currency, but what it actually means is up to debate, depending on your tastes and your culture and what century you're born in. But basically what we're meaning here by dissonant is from the simple intervals within the octave, the tritone is the one that has the most complex frequency ratio. Meaning, if you know, sound are waves, right, in a material medium, in air, in our case, and in our ears, etc. So these notes here have a frequency. These waves are oscillating at a given number of times per second, right? And that's what is measured in physics and acoustics by hertz. Now, if you put the frequency of a note and the frequency of another note, and these two notes make a tritone, that has a very, very complex ratio. For example, a ratio of an octave is 2 to 1. It's very simple, right? So basically, if one note is vibrating at 100 oscillations per second, right, 100 hertz, the one that is an octave above that will be vibrating at 200 hertz. The ratio of the tritone is very, very, very much more complex than that, which is partially why it sounds so quote-unquote dissonant or has a richer vibration pattern than these simpler intervals. And because of that, the tritone is, once again, has been treated in a very special manner in the history of Western classical music. So, like before, we can also invert these intervals. Just for the sake of review, inverting intervals means to swap the bottom note for the top note and vice versa. And we know that intervals are inversions of each other when their distances in semitones add up to 12, right? Unisons and octaves, if you invert any of those, they will invert to themselves. So either you can see that as that being inverting to themselves, or maybe as not being able to be inverted. Very uninteresting, actually. So that's what happens. Fourths, on the other hand, they invert to fifths and vice versa, right? We also saw that there are patterns that emerge, right, when we invert quality sizes, fourths to fifths, etc., and qualities too. Perfect intervals always invert to perfect intervals. So a perfect fourth inverts to a perfect fifth, and vice versa. If you'll remember the number of semitones, a perfect fourth has 5, a perfect fifth has 7. You add those two together, you have an octave. You have 12 semitones. So they are really, mathematically, we can prove that they are inversions of each other. Augmented fourth inverts to diminished fifth, right? So these two are tritones. And it's really special because not only do they invert to each other, but they are also enharmonic equivalents of each other. Another reason why tritones are so special. And a diminished fourth inverts to augmented fifth and vice versa. So here's a little table with all of the intervals that we've seen already, right? Simple intervals, excepting the octave and the unison because they really don't invert. So from second to seventh, that's what you have. Notice here that here I'm going from second, third, fourth, fifth, sixth, and seventh, and here's the opposite, right? So that other pattern becomes apparent. And the qualities now completed with the 5 qualities, major to minor and vice versa, diminished to augmented and vice versa, and perfect inverts to perfect. Okay, that's it. Thanks for watching. Next time we'll talk about intervals in the specific context of major keys.